right, so today's lesson is going to be about solving 3 by 3 systems of equations. So there is a way to do it straight calculator. If you follow model problem number 3, right here, there's an apps button, right? So this purple button right here, you hit that, and then you go and you find polysimiles 2. This calculator, my calculator right here, does not have it, but the ones at school do. So you follow these steps right here, and you literally just plug it in. So we would have gone through this in class. So what are you plugging in, right? So you're plugging in a 1, then a 1, then a 1, and then a 9. Here you're plugging in a 1, a negative 1, a negative 1, a negative 1. Here you're plugging in a 1, a negative 1, a 1, and 21. And then you just literally hit graph, which is next, and then hit solve, right? So once you do that, it'll give you the values for X, Y, and Z. But I want to show you how to do this by hand on just by hand, okay? So what you do by hand is step 1, you're going to pick a variable to get rid of. If I look at this, I'm going to work smart, not hard. So here I have plus 5y, here I have minus 5y, here I have minus 5y. So let's ignore this third one real quick, and let's look at these two right here. So I notice that if I do a plus 5y and a minus 5y, these are going to cancel out when I combine them. X plus 4x is going to give me 5x, and then negative 1 plus 4 is going to give me 3z is equal to, right? And all I'm doing is combining these. And 19 and a negative 20, when I combine that, I'm going to get a negative 1. Okay, so all I did, step 1, is I picked a variable to get rid of. I saw that y was easy to get rid of. So I combined those terms and I got rid of the y's. And now I have an x and a z. Okay, that's step 1. Step 2, now we got to pick a different pair, So I can't pick 1 and 2 anymore. Hold on. All right, sorry, my Alexa was about to interrupt me. And so now you pick a different pair. So before I chose 1 and 2. So now I'm going to choose 1 and 3 for similar reasons, right? This 5y, this negative 5y, when I add them together, these are going to cancel out. Doot, doot. Oh, x and the negative x are also going to cancel each other out. Okay, so all I have is negative 1z and negative 5z together. That gives me negative 6z is equal to, which this is working out perfect. Okay, won't always. And 2 and negative 20 is going to give me negative 18. Divide both sides by negative 6. Divide both sides by negative 6, and you get z is equal to 3. Okay, now I have z. So I can't plug it back into the original because I need z and one more to figure out what the third variable is. So why don't I just go and plug it right in here? So z is 3, right? So I have 5x plus 3z, which I'm going to plug in the 3 here, is equal to negative 1. Okay? 3 times 3 is 9. So I have 5x plus 9 equals negative 1. Subtract 9 from both sides. And then I get 5x is equal to negative 10. Divide both sides by 5, and I get x is equal to negative 2. Okay, so now I have z and I have x. So to find the third one, right, which is y, I can pick any of these right here, and I could plug in my x and my z. Um, since I like positive numbers, I'm just going to go ahead and do this one. So x plus 5y minus z. So I have x plus 5y minus z is going to equal negative 20. That negative 20 is not looking pretty, but whatever. So I'm going to plug in my x, which is negative 2. I don't know what my y is, so I'll leave that as y. And then I have minus z. What's my z? 3. So I have minus 3 equals negative 20. Okay, so combine like terms. So that's going to give me 5y minus 5 equals negative 20. Add 5 to both sides, so I get 5y equals negative 15, and I get y equals negative 3. All right, that's it. So now I have all 3 of them, X, Y, and Z, find all the values of the variable using the easiest equation. Done. All right, so that's model problem number 1. Model problem number 2, very similar. Okay, so I'm going to figure out if there's one that's easy to cancel out. Oh, of course, it's going to be harder. There's no easy one, right? So let's take a look at what we can do here. Okay, I see that if I take these two and I add them, right, I'm going to choose to get rid of the x here. And then this one, 3y minus 2y is just y. 3z minus z is 2z. And 9 minus 6 gives me 3. So I just combined the first two and I got this equation. Now I'm going to pick a different 2. Okay, I can't pick the first 2. So now, why don't I, if I see this right here and I multiply this whole thing by 2, that's going to have 2x and a negative 2x. That's going to allow me to cancel that out. Okay, so this is going to be negative 2x plus 6y minus 2z equals negative 12. And I'm going to combine that with the 2x minus 5y plus 5z is equal to 17. Okay, so if I combine these right here, right, this is going to allow me to cancel this out. 6 minus 5 is y. Okay, this is looking good. Negative 2 plus 5z is going to give me positive 3z is equal to, and 17 minus 12 is going to give me 5. Okay, so now I'm working with these two equations, and what I want to do is I want to get rid of a variable. It's easy to, if I just subtract this, to get rid of the y's. So let me choose a different color, right? If I were to subtract this right here, so y minus y cancels each other out. 2 minus 3 gives me negative 1z. 3 minus 5 gives me negative 2. Divide both sides by negative 1, and I get z is equal to 2. Okay, done. Now I'm going to take this answer that I got, and I'm going to plug it back into one of these right here. So let's go ahead and plug it. What kind of arrow is that? I have no idea. So I'm going to do y plus 2z, which is 2 times 2, is equal to 3, right? I'm plugging it into this one right here only. So I have y plus 4 is equal to 3. Subtract 4 from both sides, and I get y equals negative 1. Okay, so now I have z and I have y. Now I'm going to plug it into any of the ones on top. So why don't I just use the first one, x minus 2y plus 3z. So x, let me go ahead and change colors. X minus 2y plus 3z is equal to, what was it? Is equal to 9. So I don't have an x, so I'm going to leave that down. Minus 2 times my y is negative 1, plus 3 times z, and z is 2, and this is going to equal 9. So negative negative gives me a positive, so I have x plus 2 plus 6 equals 9. This is 8. So x plus 8 equals 9. Subtract 8 from both sides, I get x is equal to 1. Okay, and then you could plug it back into a third equation, which we didn't use, so we used the first one. Plug it into the second or third one to make sure that it works. All right, this one, again, model problem number 3 is straight calculator. Follow the steps that are here, step 1, 2, 3, and you will be able to, we would have done this in class. Okay, all right, that's it.